Hello 8th graders, this video is all about ELR 4.4, which is about isotopes and radioactivity. So you've probably heard of radioactivity before, and it sounds really complicated at first, but once you understand what's going on with the parts of an atom, it actually becomes a lot more clear. So let's jump right into it. We are going to start out with hydrogen. The reason we're going to start out with hydrogen is because I think it's the smallest one, it's easiest to understand. So take a look at these three different examples of hydrogen. If you were to take a scoop of hydrogen out in the real world, you wouldn't get the same kind every time. Take a look at what makes them all hydrogen. If you remember, it's always the protons. So since it's hydrogen, it's always got to have one proton. Will they have the same amount of electrons? Well, that depends on if it's neutral. So in this example, these three are neutral, so they're also going to have one electron. But they're not going to have the same mass. This one is hydrogen 1 because it only has one thing in its nucleus, one AMU. This one's hydrogen 2 because it's got an extra neutron. And this one 3 because it's got three things and each thing has one AMU. So the thing that's making them all different is the amount of neutrons. And we have a name for this. Isotope is the word we use to talk about different types of atom. So there are three isotopes of hydrogen on your screen. Isotope is just a Greek word that means type. You can have different amounts, or you can have different types of an atom by changing the amount of neutrons. Pause this if you need to add these notes to your paper still. So neutrons have very special powers. Let's imagine that you're building an atom and you start off with two protons and you just set them right next to each other. Just like when you've played with magnets, if you took two protons and set them next to each other, they both have positive charges. Like magnets, they would push each other apart, they would repel. So in order to make atoms stick together, you have to add neutrons. So you can sort of think of neutrons as the glue that's holding the atom together. Well, if you don't have enough neutrons, this is what we call nuclear decay or nuclear fission. It's also what radioactivity is. So if you had a really big atom, let's say, and it didn't have enough neutrons, that means that what's going to happen is those protons are going to slowly push each other apart and then rip the atom right in half until you have two separate atoms. You didn't get rid of anything, you just took a big atom and split it into two. When this happens, a whole bunch of stuff comes flying out, it gets really hot, and it's super, super dangerous if it's happening to a lot of atoms at once, and that's what a nuclear bomb would be. So the question becomes, well, if neutrons are the glue, why can't we just make a really, really huge atom and just keep adding neutrons to it to stick them together? You probably remember that the periodic table only goes up to element number 118, and so why can't we just slap a whole bunch of neutrons together and keep going and make element number 2000? Well, neutrons also do this other really interesting thing. If you have too many neutrons near each other, they do this thing where they turn into protons. So imagine you're making a really big element. You stick a bunch of protons, you stick a bunch of neutrons, and you just want to keep going and going. Well, now there are too many neutrons near each other, they turn into a proton, and protons push each other apart, and then your element will rip apart. So when they're making new elements in the laboratories, when they made element number 119, they literally shot a bunch of protons and neutrons at each other and made them stick long enough to prove that they had made a new element, but then the neutrons flip into protons and the element rips apart. So those elements only lasted for a few nanoseconds, but they technically existed, so they did make a new element. So we have words to talk about this element ripping apart business. We call an element or an atom unstable or radioactive when it doesn't have the right ratio, when the two things aren't keeping the atom together, when it rips apart. And we measure how unstable something is, because some elements are unstable, but they're able to hold it together for a little while. Other ones just rip apart right away. We measure how unstable they are with something called half-life. And it's the amount of time for half of that material to rip up and break apart. Let me show you an example. If you took plutonium, which is a radioactive element, let's say you had 1,000 grams of it. Well, plutonium has a half-life of 24,100 years. What that means is that if you were to wait around for 24,100 years, after that amount of time, half of your material would have ripped apart because it was radioactive and flown apart. So that's a pretty long half-life. Plutonium's pretty good at hanging around. The newer elements, the ones that are really big on the periodic table, they have half-lives of about like 1/10 of a second. That means that every 1/10 of a second, half of it has ripped apart into smaller atoms. Your last step for this lesson is to go into the Isotopes Gizmo. So you're going to go to explorelearning.com and open up the gizmos and open up the one that is about isotopes and fill in the paper that's attached to this lesson. There is a quiz underneath the gizmo. That's going to be your closure for this lesson. That's the thing that I'm looking at in order to see who I need to add extra help to. So please head off to the gizmos now.